Today we have to find out the equation of compositions of the two simple harmonic motions having same time period and again that particle which is travels along the same path. Means here we want to take the single particle which produce simultaneously two simple harmonics motion having time period is same, again which is the travels along the same path, but their amplitude and initial phase are different, right? So here we want to see the equation for the first SHM. What we get there? X1 which is equal to the, what we get there? A1 into the sine of omega t plus phi 1. Right? Now this will be the equation 1. It means that this will be the equation of first SHM. Similarly, we want to write down the equation for the second SHM. That is x2 which is equal to the a2 into the sine of omega t plus phi 2. Right? Now this will be the equation number 2. Now here this will be the simple harmonic motions of a particle having same time period. Again their path is also same, only their amplitude and their phase are different. Then what happen? Here these two waves are there superimposed. So from that we get the resultant wave. Here resultant wave x which is equal to the, what we get there? Simply addition of this one, that is x1 plus x2. Now here we want to substitute the value of x1 and x2. Here the value of x1 is a1 into the sine of omega t plus phi 1, right? And the value of x2 is plus, what we get there? a2 into the sine of omega t plus phi 2. Right? Now this will be the equation. But now here we want to treat this equation just like sine of a plus b. Here also sine of a plus b, and we know that the formula of sine of a plus b. But what we get there? Sine of a plus b which is equal to the, what we get there? Here we get the sine of a into the cos of b, right? Plus cos of a into the sine of b, right? Now this will be the resultant equation. Now using this one, here we want to expand this one. So what we get there? Here x which is equal to the, what we get there? Here we want to keep this a1 is as it is, and now expansion of this sine omega t plus phi 1 using this formula, what we get there? Now this will be the a, this will be the b. So that's why what we get there? Sine of omega t into the cos of phi 1. Right? Now this will be the first term. Now the second term is what we get there? Cos of omega t into the sine of phi 1. Right? So this is about the first one. Now the second one. Plus this a2 is as it is. Then again here we want to treat this equation just like the sine of a plus b, and their expansion is what we get there? Sine of omega t into the cos of phi 2, right? Plus what we get there? Cos of omega t into the sine of phi 2. Right? Now here we want to multiply to this term by a1 and to this term to the a2. So what we get there? Here a1 into the sine of, what we get there? Omega t into the cos of phi 1 plus, now the second term, what we get there? a1 into the cos of omega t into the sine of phi 1. Similarly about the second term or second bracket, what we get there? Plus a2 into the sine of omega t into the cos of phi 2 plus a2 into the cos of omega t into the sine of phi 2. Right? Then in that, see here, this will be the first term, this will be the second one, this will be the third term, and this will be the fourth one. Now, if we see the first and third term, then in that sine omega t is common. In second and fourth one, their cos omega t is common. Right? Here sine omega t common, here sine omega t. So take outside. So what we get there? Therefore, what we get there? X which is equal to the, here we want to take sine omega t is common. So sine of omega t. Inside the bracket, what we get there? A1 cos phi 1, A1 into the cos phi 1 plus, in second one, what we get there? A2 into the cos of phi 2. Right? Similarly, in second and fourth term, here cos omega t is common. So take outside. Plus cos of omega t inside the bracket, what we get there? A1 into the sine of phi 1 plus A2 into the sine of phi 2. Right? We get this equation. Now, in that, here A1 and phi 1 is a constant. Again, A2 and phi 2, which is also constant. For our convenience, again, we want to take the another one constant, which includes the A1, phi 1, A2, phi 2. So what we get here? Let's. Here, we want to consider here R into the cos of del, which is equal to the, what we get here? Here equation is A1 into the cos of phi 1 plus A2 into the cos of phi 2. Right? Now, similarly for this one, what we get there? So this will be the R into the sine of del, which is equal to the, here A1 into the sine of phi 1 plus A2 into the sine of phi 2. Suppose here if we consider, this will be the equation number 3, and now this will be the equation number 4. Right? Here R is the resultant amplitude and del is the resultant phase. Right? If we substitute these values in this equation, then what we get there? Therefore, x which is equal to the, here sine omega t is as it is, sine of omega t. Right? Instead of this bracket, we want to write down simply R cos del. Right? Plus, now here cos omega t, which is also as it is. Then here, instead of this bracket, now here we want to simply substitute the R sin del. So R sin del. Here, if you take the R is common, so what you get there? R inside the bracket sine of omega t cos of del plus what you get there? Cos of omega t into the sine of del. Now see this equation. Here what you get there? Sine of a plus b is nothing but the sine a cos b plus cos a sine b. Right? Here, if we use the same result here, right, it means that instead of this bracket, if you write the equation just like this one, so what you get there? X which is equal to the R into the sine of, here instead of a, here we want to write down the omega t, and instead of b there, we want to write down simply del. Right? And now this will be the equation of resultant simple harmonic motion. If we see the equation 1 and 2, equation 1 and 2 which also represent the equation of the simple harmonic motion, again the resultant equation which also represent the simple harmonic motion, means the resultant of two simple harmonic motions are simply simple harmonic motion. Right? Suppose this will be the equation number 5. Now we want to find out the resultant amplitude and resultant phase. Now equation for the resultant amplitude. resultant amplitude, that is capital R. So what we get there? Here we want to use the equation 3 and 4. Here we want to square and add the equation number 3 and 4. First of all, we want to take the square, and after that we want to take the addition. So what we get there? Squaring and adding, square and add equation number, which one? 3 and 4. What we get there? Here take the square, and after that you want to add that. What we get there? R square into the cos square del plus second one R square into the sin square del, which is equal to the. Similarly here we want to square and add the same one. So what we get there? Here a1 into the cos of phi 1 plus a2 into the cos of phi 2. This will be the bracket. Plus now the square of the second one. What we get there? a1 into the sine of phi 1 plus a2 into the sine of phi 2. Right? Again here we want to take the square of this one. But what happened here? If you take the r square is common here, then inside the bracket what we get there? Cos square del plus sin square del. But we know the trigonometric function. Sin square theta plus cos square theta is nothing but the 1. Right? So that's why instead of this one, simply we write here r square. So r square, which is equal to the, what we get here? Now we want to expand this one. What we get there? Here we want to treat this equation just like simply this will be the a, and now this will be the b. That is a plus b bracket square. So what we get there? A square plus b square plus 2ab. So what we get there? a1 square into the cos square phi 1 plus into the cos square phi 2, and third term is there. What we get there? 2 a1 a2 into the cos of phi 1 cos of phi 2. Right? So this is about the first bracket. Similarly the second bracket, what we get there? Plus a1 square into the sine square phi 1 plus a2 square into the sine square phi 2 plus 2a1 a2 into the sine of phi 1. In this equation here, a1 square, here also a1 square. Suppose here this will be the first term, second, third, fourth, fifth, sixth terms. In that, inside the first and fourth term, there a1 square is common, so take outside. So what you get there? So this will be the r square, which is equal to the a1 square. Inside the bracket, what you get there? Sin square phi 1 cos square phi 1. What you get there? Sin square phi 1 plus cos square phi 1. Right? Plus now in second and fifth terms, what you get there? a2 is common, so what you get there? a2 square. Inside the bracket again there, sin square phi 2 plus cos square phi 2. Right? Now this is about the second and fifth one. Now third and sixth one, what you get there? Plus 2 a1 a2, so this will be the common. Then here different terms are there. Cos of phi 1 into the cos of phi 2 plus what you get there? Sin of phi 1 into the sin of phi 2. Right? Then here what we get there? As per the trigonometric function standard, what we get there? Sin square theta plus cos square theta is 1. Here also sin square theta plus cos square theta is 1. Right? It means that instead of this bracket, we want to substitute the simply 1. Right? Again this will be the 1. Again this bracket, which is also 1. And for this one, for this equation, here what we get there? Here just like the cos A cos B plus sin A sin B, and now this will be the expansion of cos of A minus B. It means that instead of this one, we want to substitute the cos phi 1 minus phi 2. Right? So what we get here? Therefore, r square, which is equal to the Sir, in this one, the value of this bracket is 1. So simply here what you get there, A1 square plus, in the second one what you get there, again the value of this bracket is 1. So what you get there, plus A2 square plus, what you get there, 2A1 A2. And now here, now this will be the expansion of cos phi 1 phi 2. Right? So what you get there, cos of phi 1 minus phi 2. Right? Now this will be the value of r square. Now taking under root on both the side, what you get there? R, which is equal to the under root of A1 square plus A2 square plus 2A1 A2 into the cos of, what you get there, phi 1 minus phi 2. Right? So this will be the equation of resultant amplitude. Right? Suppose this will be the equation number 6. Right? Now we want to find out the value of resultant phase. Now resultant phase. Resultant phase, that is del. Here we want to find out the value of del. So what we get here? Here del, which is equal for that del. Here again we want to use the equation number 3 and 4. So take the ratio of equation 4 to equation 3. Taking ratio of equation 4 to equation 3. What we get there? See here. First of here, r sin del upon, what you get there, r cos del. Right? Which is equal to the, here what you get there, this will be the A1 sin phi 1 plus A2 into the sine of phi 2 upon, what you get there, these terms. So what you get there, A1 into the cos of phi 1 plus A2 into the cos of phi 2. Here r get cancelled, but sin del upon cos del is nothing but the tan del. So what you get there, tan del, which is equal to the, what you get there, this term is as it is. Which one? A1 into the sine of phi 1 plus A2 into the, what you get there, sine of phi 2. Here what you get there at the denominator, A1 cos phi 1 plus A2 into the cos of phi 2. Right? Now here we want to find out the value of simply del. So transfer this tan to the sides. So what you get there? Therefore, del, which is equal to the inside the bracket, what you get there, del, which is equal to the tan inverse of inside the bracket. Now here we want to write down as it is. So what you get there, A1 into the sine of phi 1 plus A2 into the sine of phi 2 upon, what you get there, A1 into the cos of phi 1 plus A2 into the cos of phi 2. Right? Now this will be the equation of resultant phase. Right? Now this is about the compositions of a 2 SHM. So this will be the equation of composition of a 2 SHM, that is resultant SHM. Then this will be the equation of the resultant amplitude, and now this will be the equation of the resultant phase. Now see all the equations once.